Association of Structural Engineers, also known as IS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IS-Struct-E is registered under the Society's Registration Act 21 of 1860. IS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IS-Struct-E has collaboration with various international professional like-minded associations and institutions. IS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IS-Struct-E's activities are widely appreciated and known for quality technical contents. IS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines and a monthly newsletter. IS-Struct-E's publications are becoming popular with time. IS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IS-Struct-E is available on its website www.isstruct-e.co.in.
Hello.
Yes, sir. Yes, sir. Please start, sir.
Shall I continue? Oh, my voice is
Yeah.
audible.
Yes, sir.
Dear friends, welcome to the webinar. Today, the topic of the webinar is on latest development in design of post-installed rebars. Our speaker of the day is Engineer Kamalika Kundu. She is young, bright, technical expert on post-installed fastening and fire stopping. She is currently working as regional course and senior manager at Hilti Asia Pacific Private Limited. She graduated from Malviya National Institute of Technology, Jaipur, and thereafter did her master's from Virginia Tech, Bells, uh, Blackborough, from United States of America. Her research interest includes concrete, post-installed anchors, post-installed rebars. She is currently working as regional course and senior manager at Hilti Asia Pacific Private Limited, located in Singapore, and is responsible for markets like India, Australia, New Zealand, Malaysia, Singapore, etc. in the South Asia Pacific region. She has been associated with field of fastening techniques and fire protection for over a decade. Regarding the brief of topic of the webinar, post-installed rebar system are often used in construction for uh, concrete and are quite popular as they allow flexibility in design and during construction. They are used both in new concrete as well as for retrofitting of the concrete structures. Depending on the product and post-installed rebars could provide significantly higher bond performance as compared to the cast in situ rebars under uh, under bad conditions. In the past, the high bond performance could not be achieved in design. Recently, the European Organization for Technical Assessment published guidance for seismic design for post-installed rebar connection, which improved the bond splitting behavior. This document covers the design of post-installed rebar moment resisting construction, static, quasi-static, and seismic loading conditions without the need and overlap supplies configuration. Now I request Madam to share her experience on the subject.
Thank you,
Please.
sir, for introducing the topic as well. Let me just share my screen. I hope I'm audible and my screen is visible.
Yes,
Yes.
ma'am.
Yeah. Okay. Once again, hello to everyone. I'm Kamalika Kundu. And sir has already introduced myself, so let's directly get to the topic. And before I start, apologies for my throat. I hope you're able to understand, I just have a bad throat today. So my topic is latest developments in design of post-installed rebar. And in today's sessions, I will be covering the following topic. I was told that many students would also be joining us today. So I would start with very basics of post-install concrete to concrete connections, introducing post-install rebar, and then move on to basic design methods and more complex design methods that have been introduced recently. So when I graduated, did my bachelor's, the only rebar connection that I was aware of was basically the cast in rebar, where you have a rebar cage and then you pour the concrete and basically it's casted in. And I'm sure for most of us that is still the case. And this is good when you are building new concrete structures. But what do you do when you have to connect new concrete structures to existing concrete structures? There are different ways to do it. You can either chip off a part and then uh, tie in the new rebar and so on. You can core and then grout the rebar, or you can completely demolish the structure and rebuild. Most of the time, these methods are not the most economical one. They're time consuming and labor intensive. Another way to do it is our post-installed rebar, and that's where today's topic comes into play. Post-install rebars are nothing but in a hardened concrete, you drill a hole, you clean it, you inject an adhesive or mortar, and you put the rebar in it. Wait for it to harden, and then you can cast your new concrete slab. So this sort of connection is called post-install rebar. Here is an example of post-install rebar where you see rebar being connected to the slab here. Before we proceed, I would just like to share a reminder that this is for concrete to concrete connections. Many of you may also be familiar with post-install anchoring applications where we connect the steel connection or a base plate to the existing concrete structures. Obviously, the design principles and the force transfer principle, everything is different. And in today's session, we will focus only on the post-install rebarring, where you have a existing concrete, a new concrete, there is a rough end interface between them. And then you have a rebar and mortar. So once again, which are those applications where we would need such a connections? It could be for extensions of existing structures. That is usually your lap splices. And then you have your strengthening applications where you have your concrete overlay and so on. And then you could have extensions of members or for flexibility in the job site. Those are the end anchorage applications. To give you some real life examples, here we have your concrete jacketing application, your slab extension, excuse me, slab to wall connections, your column extensions and so on. There are many applications where post-install connections come really handy. Also, please bear in mind, though we are talking about rebar, there's a distinct difference between post-install rebar and cast-in rebar in terms of the force transfer mechanism. In case of a cast-in rebar, though you have a rebar and concrete and it's directly transferred through the bearing and struts, whereas for post-install rebar, there's a mortar surface in between. So the forces are transferred from the rebar to mortar and then from mortar to concrete. And this interaction is significantly dependent on the product being used. And therefore, over the last maybe 2 decades or so, many guidelines have been developed. And as you can see, maybe the first one was around 2006, 2007, which was your TR023. This was issued by an European organization. And it basically compared, that the post-install rebar, if it performs the same as cast-in, if its behavior is similar, then what it said is you could use the design guideline for cast-in rebar with certain modifications. And over the years, they developed more guidelines. The reason for that is when this TR023 came, there were some practical challenges. For many of the applications, we couldn't cater to the application. For example, the embedment depths required for those applications, if you went by this theory, were really long, and then they were not practical to execute. There was also research which said that, post-install rebar bond strengths are much higher than cast-in, but there was nothing in place to take advantage of that. And over the years, more assessment documents were published, which allowed to take advantage of the increased bond strength of post-install rebar, which we will talk in the following slides. Also, today I'm talking mostly about this European guidelines because in India there are no assessment or design guidelines for post-install rebar, and for most part we do follow this European guidelines. Here is an overview of the different connections that I just spoke about and the different guidelines that are available for each of those applications. The concept that it follows is for each of those applications, there is an assessment document. So the post-install rebar is assessed for use in those applications. And based on that assessment, an approval document is issued. And the characteristic values given in those approval documents is used for designing using the design guidelines. I hope all of you are with me so far. And I will just go one by one. The very first one, which you may be the most familiar with, is your design like a cast-in bar. Just like your cast-in rebar, post-install rebar also needs to be checked for your splitting behavior, pull-out, and yielding, with a few differences to keep in mind. I'm not going into each of these because I assume you all are familiar with the splitting, pull-out, and yielding behavior. So in splitting behavior, the presence of a adhesive or motor around the bar may enhance the splitting performance, but this is product dependent. And as I said, there are different assessment documents to assess this behavior. Also, in terms of pullout, because of the motor, the failure could happen between your steel and motor or the motor and the concrete interface, which is again product dependent and is assessed as per the assessment reports. For yielding, it's the same as cast and rebar. There's not much difference. It depends on the steel. Here, here is a snapshot of what the testing regime looks like in one of the approval assessment documents. If you look over here, though I won't be going in detail, if you see here, we have some reference tests in low and high strength concrete for varying embedment depths. We also have different installation conditions, for example, dry concrete, saturated concrete, different installation temperature, different installation direction, and so on. And recently, there has also been an addition of seismic assessment for those applications. Based on this assessment, as I said, there's an approval report that is issued. In this specific case, there's example for static and seismic resistance. And as you can see over here, the values for both static and seismic in this case are same, with the exception of the concrete grade for which it can be used. Basically, what this gives you is the design stress values that's to be used for design. As per the European document, it says that if you prove it to be equal to cast-in, if you prove that post-install rebar is equal to or better than cast-in terms of behavior, then you can use the design rules for cast-in rebar in the Eurocode for post-install rebar with some spacing and edge considerations. Here I have the equation from Eurocode, which is for your lap splicing, the lap length. Over here, we have the anchorage or development length. And this equation is very similar to that we find in IS 456, as you can see over here. And but the only thing over here, they change is the design stress value. Instead of cast-in, we take the FBD value for the post-install rebar, which is given in the approval document that I just showed. In Eurocode, in addition to the basic anchorage or the development length, we also have the different factors for your form of bar, for your edge and spacing effect, for your confinement effect, for your transverse pressure, as well as the extent of lapping. There's also guidelines given for the minimum lapping length. And these are just some parameters. So it's very straightforward calculation, very easy to do. I'm sure many of you may be familiar with this. And for seismic, the only difference here is that the FBD value would be that corresponding to the seismic assessment. And of course, the edge and spacing requirement corresponding to seismic for post-installed rebar are to be followed here. So that was a very quick overview of what we do for the cast-in, and I assume most of you are familiar with this. The most recent addition to post-install rebar design are basically your end anchorage connections and the shear friction application. For the end anchorage application, we also call it design with improved bond splitting behavior. So as I said that in the past, when people started researching on post-install rebar, they saw that we can achieve really high bond strength or pull-out values with post-install rebar, but there were no design guidelines to leverage this. They restricted the design to that of a cast-in bar. Though you can see over here how the bond strength of cast-in versus the post-install rebar can be much higher, and so on. But recently, so the EAD, I'm just noting the number, these two EAD and the TR069 was published, which allowed to leverage this property of the post-install rebar. I will not be covering the assessment document that is not officially published in the EOTA website, but I will be covering the TR069 document, which covers the design aspect. So basically, this document covers your moment resisting connections, your column to slab foundation, for example, your wall to slab foundation, your beam to column connections where you have some moment coming in. So that's where this document comes into play. Now the TR069 design principle sort of merges your cast-in design rules as well as your anchorage design theory. So these are the three failure modes that are being checked in the TR069 document. The very first one being your bar yielding, which most of you may be familiar with, where we are just checking the steel strength and dividing it by a safety factor. The next one is the concrete cone, and this is the same as your post-install anchors concrete cone check. If those who are familiar with would realize that this is the same equation. We have your basic concrete cone strength, your area factors, spacing factors, and so on, which we divide by the partial safety factor. Then we have the bond splitting, which I will cover in more detail in a minute. Here, the most important thing to note is this bond splitting value, which is multiplied by your bar dia and the embedment length and so on. And this check is done for the highest stress bar, whereas the concrete cone check is done for the group of the bars. You would take the minimum of the three, and that would govern as the design value of the resistance. So these are the three checks. So now this is an illustrative sketch to show what's happening. So in case of cast-in rebar, you have your FPD value for cast-in, which is basically they limit after a certain value, you can't go further. So that's the upper cap. Whereas if you go by TR069, then it would allow you to exploit the higher bond strength as you go further away from the edge. So this chart shows a constant embedment and varying concrete cover. So if you go further away, then at some point you will be able to exploit the ultimate or the maximum capacity of the not the ultimate, sorry, the maximum possible design capacity of post-install rebar. And between a certain cover, you are limited by the splitting bond resistance. Now in this sketch, we have varying concrete cover. Your concrete cover is constant and embedment length here is varying. So again, we are capped over here by your cast-in rebar bond stress. When it comes to TR069, when you have a small cover, if you see over here around 70 or so, then the bond degradation starts. And if you have a large cover, then it goes up to 20D when your bond degradation starts. Basically, your uniform bond model that we say for post-install anchorage, that also is limited by 20D where we can exploit. But when we go deeper and deeper, it's no longer a very linear model. So the bond splitting model that has been in the TR069 factors this in its calculation. Excuse me. So the advantage of this method is that for those applications that I showcased, the moment assisting applications, sometimes if you go by the cast-in theory, you will end up with lengths that are not practical. Bond splitting resistance method allows you to come up with shorter embedment depths, which are more practical and reasonable and has a technical basis for it. Over here is the equation for your bond splitting behavior. Over here we have the factor AK. There are too many factors, don't worry about them. It's just a plug and chug model. But what it does, it takes the form fitting factor, influence of your concrete strength, bar dia. Basically, if you have any bar dia beyond 25, it starts to negate the effect because it would have a worse effect on splitting. And similarly, it takes the influence of your edge dia ratios and so on. Here is a pictorial illustration of what's happening. So we have, so for example, this is your steel yielding. This is the bond splitting as per the Eurocode. As per TO R069, if you were to plot, this would be your bond splitting. And this is your concrete cone curve. And let's say this is your LB minimum. If you go by TR069, so the embedment length, as I said, that you would come would be shorter than what you would come across by the, in for most cases, shorter than what you come across by the first method that we discussed. Because over here, it's the intersection of these three, whereas for the TR069, it's the intersection over here that would go on. Over here is a video that I would like to play for you, which shows the two connections, one using cast and rebar and post-installed rebar. You can just see how it behaves. You can see the swing. It very well covers the curve shows. So this is stop. So you can see over here the complete connection crushing out. So that was a quick overview of your TR069 design method. If you want to go through the design method in more detail, please visit the EOTA website. It's European Organization for Technical Assessment. If you just search on Google, you will reach their website. If you go to their published document EADs and the technical reports, you can download for free the TR069. It's not a very big document. It explains the whole theory in much more detail, what's happening there. The last design method that I would like to cover today is the shear friction application. So the assessment is covered in EAD 332347. And then the design method itself is covered in TR066. I see a comment here. I hope my screen is visible. Someone messaged that the screen is not visible.
Visible.
Visible. Okay, good. Okay, let's see. So this is the basically a shear friction application. So where would this application come into play? For example, your flow strengthening application, foundation strengthening application. I'm sure many of you are structural engineers here. You may be familiar with many of applications where the concrete overlay comes into play. For example, your shear and fill walls and so on in both building and infrastructure projects. And this is a very recent application, like just like 2020, this document was published, and it has a clear procedure for design and static or static seismic as well as fatigue application. as I said, that this document could be used only if the post-install rebar has been qualified for use as per this particular assessment document. Now, the shear resistance according to TRO 66 is dependent on all of this force transfer mechanisms. We have the aggregate interlock that is happening right over here at this interface. I hope you can see my laser pointer. Then you have your shear friction acting up, your dowel action because of the connector that's between the two layers. And you also have strut acting between those connectors through the concrete. So those are the force transfer mechanism which TRO 66 accounts for. Here is again a very wonderful complex equation, but I'll show you how this ties in with the force transfer mechanism that I just showed. So this very first component of the equation, which is basically for calculating design value of shear resistance, is to address the aggregate interlock. The second component is your shear friction value, and then is your dowel action, and then we have your strut resistance. So that's how it factors. So there are a bunch of factors. Many of them are given in your approval document, and the rest can be directly taken from TRO 66 document. So this is basically giving you the designed value. So besides this, so maybe before I proceed, so for seismic, we change the factor to alpha seismic and so on. But before I proceed, so again, just like the 6.9 document, this document is just a 15-page document that you can download from the EOTA website. So what it says is after calculating the design value, so for the connector itself, for design in your concrete overlay as well as the existing concrete, the design rules of anchoring apply. That's covered in the Eurocode 2 Part 4. And also the document gives you more guidance on the surface roughness, surface preparation, and the coefficients that are to be considered for design. Because in this presentation, I felt it would be too much to go into that much depth, so I have not really covered into that much detail. But please take the time to go through the TRO 66 document. I would like to play another video that shows a shear infill wall being tested, and you would see the drift is being changed. So before I head to conclusion, I would like to share, just give me a minute. I hope you can see the document that I'm sharing. So as I was mentioning that the document, this is the TRO 66 document. So it says for the connectors, you would have to design as per the Eurocode. They also provide guidance on the minimum reinforcement. Then they have also more information on your surface preparation, your, I think the surface factor, the roughness factor, and so on, which are to be considered for designing this application. It's just like a very small document, quite straightforward. And in addition, I would like to show you, maybe I'm not able to share. Anyways, I think there's some issue. So that was a very quick snapshot of the different design methods that are available. So when you're designing rebar as a cast-in rebar for your lap splices, when you have your rigid connections, for your column to foundation connections, beam to column connections, and so on. And then you have your concrete overlay applications. So these documents are based on intensive research, and they allow the manufacturers to qualify the post-install rebar for these applications and allow the designers to design for those applications. So So as I said, so there are different assessment methods for each of those three categories of applications that I mentioned. And the design is also covered in three different documents for each of those applications as listed here. And they cover both static and seismic loading, and the approval document, which is the ETA, covers the performance data. So if you remember, all the equations that I showed have many of those performance linked data which are to be made use of. It can be complicated, so there are quite a few design softwares out there that you can make use of that will help you design in a safe manner. With that, I would like to conclude my presentation and open for questions.
Thank you, Kamalka. Can I ask you few things before I will open for questions?
Yes, sir.
Kamalka, just two small things in the mind that this post-installed rebars, what would be its design life in the marine areas?
Sorry, what would be the design life
In the marine areas, coastal areas.
So it would depend on the exposure. So in some of the assessment, we have high alkyne and all of those of corrosion conditions. So in general, the approval documents, there's an ability to qualify for 50 to 100 years under normal conditions. The marine would depend on the situation, the exposure conditions, and so on.
And the second question is, what about the performance-based design? You have explained that you need design for aggregate interaction, shear, bond, and blah, blah, blah. I mean, this non-linear analysis for the earthquake loads, can we have this performance-based design for such connections?
Sorry, I didn't catch your last part, sir.
I said the performance-based design for such installations.
So this is the whole thing that I just presented is performance based in terms of the product. So the product itself is qualified for use in those applications, and then the performance parameters are considered. Now there are also studies. So besides the product itself, so there are large scale studies that have been done to check how the behavior is in terms of the whole structure, and then modeling and all of that has been done. So unfortunately today I did not present any of those, but we have tested both at a product level as well as at the application level.
Now, Vikas, please ask the persons to put questions. Vikas?
Yes, sir. Yes.
Please ask the
Yeah, ma'am.
person to
There
put
is a question. Can we drill and install rebars in already constructed pre-stressed concrete beams which has been pre-stressed? It is from Mr. Indrajit Ghai.
Okay. So as long as we are not damaging the pre-stressed tendons, but in post-install rebar depends. So post-install rebar, I mean the pre-stressed sections are many times heavily reinforced, so maybe not advisable, but it would depend. If we can do so without damaging the tendons, then maybe yes.
Okay, ma'am. Mr. Gopal Krishna asks, how do rebarring perform in case reinforcement are out of center line at different levels and reinforcement bar has been joggled?
Sorry, can you repeat the question? Maybe I'm just trying to find the question. Can you repeat the
Yes.
question, please?
Yeah, ma'am. Yeah, ma'am. One second. How do rebarring perform in case reinforcement are out of center line at different levels and reinforcement bar has been joggled?
Has been joggled. So I think when we model the rebar, we take its spacing and edge varying. So I'm not getting the question. So uh, they may not always be in the center line anyway. And there is like a 5% deviation that is allowed when we are installing the rebar. Like 5% deviation they consider anyway.
Okay, ma'am. Okay, ma'am. Mr. Uma Maheshwar, what about the fire strength of a joint?
So today I did not explicitly cover the fire resistance. So some of these documents do cover the fire resistance part as well. So in the fire scenario, the bond strength of these products would drop further. So that has to be accounted for in the design. And there are models for it in place to design it.
Okay, ma'am. And Dr. S.P. Anchuri sir asked, uh, it's seen that designs correct, but failures are due to incorrect execution. How to avoid it? Uneven plaster thickness over concrete surface is commonly observed.
Yes. Unfortunately, that's the very sad reality. And today, I again did not cover. I focused on the design because I was told mostly structural engineers would be joining in. But we also educate on proper installation. So those are the site checks. So there are like, as I'm in Singapore, that I come across many of these different practices that they are following, and to overcome this installation challenges, and again it varies country to country. So skilled labor, we have attrition, people change, uh, but they have very stringent training models in many of these countries where they're continuously training to make sure that the installation is properly done, and people understand the importance of these small sort of things, because if you don't have the concrete, no matter how strong your adhesive product that you're using, and if it has not been compacted properly, if the edge is not proper, the plaster is coming off, then it will not work. So the only way to do is proper training and supervision.
Thank you, ma'am. Mr. Shahrukh Ahmed asked, if instead of anchoring post-installed bar in the member, our requirement necessitates to drill through the member, what provision is available to?
Through and through, so it's sort
Uh,
of an hello, yeah.
yeah, ma'am. Yeah. What
So
provision is available to adequacy?
yeah, so the through connection, so it's not exactly under the repair. We usually consider under anchoring. So there's no direct provision for it as far as I'm aware. So it's usually taken care through the engineering judgment. So there's no
Okay, ma'am.
guideline as far as I know.
Okay, ma'am. Mr. Jayad, what would be the standard depth we can go for in the critical area? Shall we consider 10D or go for less depth?
I mean, the whole purpose of my presentation was that we need to design. So there's no thumb rule. From what we have realized is just a 10D or 15D uh, may not cater to your design needs. So you need to always design to optimize, because there are so many factors that come into play depending on the application you are designing it for. So I always encourage, please design instead of going by a load table or using any thumb rule.
Yeah, ma'am. Mr. Krishna Rao asked, will it be applicable whatever lab tests conducted in Europe for Indian weather conditions and workmanship? Is
Yeah.
there any additional provision taken care?
Yes. So if you see these approvals, so that as I said, there are different installation temperatures that are considered. So though the actual test has been, I mean, the reference test has been done at a specific ambient temperature. So they also provide provisions for higher temperatures, which is the case for most part of India. And then in terms of the installation quality, so there are like installation quality parameters which are there. So obviously, if you follow the rule, it says that these rules are valid only if the installation is done by someone who is trained to install the product. So any random person who has no knowledge on the topic, if they're installing, so the design guideline, and that's true for our reinforced concrete also, will not be able to cater to that. So a certain level of knowledge is expected, and it does cover different temperature ranges.
Okay, ma'am. Mr. Kamal Singh asked about minimum spacing criteria between PIR.
So it's there in the document. I don't remember it completely off uh, my head, but it's like three
It's 5D. Center
5D.
to center,
Thanks,
it's 5D.
thanks, Shana. So it's 5D.
Yeah, ma'am. Mr. Annamalai Chelappan is a Profis software was a standard loan free version earlier. It was very useful. Now it is a paid version. How can we design with only a handbook of Hilti?
Yeah, I think the basic version is still available. Shana, please correct me if
Maybe
I'm wrong.
maybe I take this.
Yes.
So Profis is basically available in two versions. One is the premium, which is the paid version, and the second is the basic, which can still be used by everyone. It allows you to avail all the features, basic design criteria. So it's still there. And I mean, a handbook is not there with Hilti, so we still follow the codal provision. So I would say let's go by the design guidelines, and Profis is an enabler.
Yeah.
Thank you, sir.
I had to rely on Shanak on this because it's different in each of our countries. So you would know best what's in India. Yeah.
Okay, okay. Ma'am, what is the difference between normal rebarring and post rebarring?
So as I think I go to very beginning of my presentation where I say where normal cast and rebar, or maybe I just share my screen again, just pictorially um, to show. So normal cast and rebar is what we know right after graduation, where you have a rebar cage. I hope you can see there is a rebar cage, and then you pour the concrete. So basically, your rebar is casted in. Whereas in post-install rebar is basically there's already a concrete member, and then you are drilling a hole in the hardened concrete, and then you are trying to attach a rebar to it. That's post-install. I hope that was the question.
Any more questions?
Yes, sir. Some more questions are there.
Please continue.
Yeah, Mr. Ranjil P. Ramat, how can the installed bar replace an L-shaped anchorage designed with a strut and tie model with a node anchorage? For example, a pier balance anchored into the foundation.
Sorry, which question is this? By whom?
Mr. Ranjil P. Ramat asks, how can the installed bar replace an L-shaped anchorage designed with strut and tie model with a node anchorage?
So as I said, for post-install rebar, obviously because you're installing it in a hardened concrete, it has to be straight. And I mean, we had in the past our strut and tie model, which are some manufacturer specific and so on. But all of this has been factored in into the design guidelines that I shared today. So it's not like a one-to-one change that we are doing, but for the load applications that are happening, the design guidelines take care of that. That I just described.
Yeah, Mr. Kalai Yarasaj asks, can this code reduce the minimum drill dia and minimum embedment length of rebar? Example, for 12 dia rebar, drill dia will be 16 and minimum embedment will 10 times of dia.
So the design method does not change your drill dia because the dia is dependent on the rebar. You need a certain amount of adhesive around it. The embedment itself would depend on the application and design. If as per the design method you're doing, you end up, let's say you are designing as per the cast-in principles, and later for that application you're designing as per TRO 69. If it's a rigid application, then you may end up, but then you have to comply with the minimum embedment requirement for that application.
Okay, ma'am. Mr. Ranjil Piramat again asked, how far a Hilti anchor can be positioned to make a lap to an existing reinforcement as a non-contact lapse?
So this dimension is given in the TRO 23 or now the EAD 887 document. So Shanak, do you remember the value? Or it's the right 1.3 something? I think it's there in the document. If you, instead of just guessing the value, I think it's better to read through.
Yeah, how far a Hilti? I'm not able to get the question also. How far Hilti anchor can be positioned? There is a maximum. There is a spacing that's around 40 millimeters.
The spacing is given in the document, so I don't remember it. But if you just go through the document that I just mentioned, it's mentioned.
Yeah, ma'am. Two questions are on the chat box. Is any study or design criteria on post-install reaper in fire load?
Sorry, in the fire load, yes,
yeah.
The fire one, I just said that today I did not cover, but these documents do cover fire also, some of them. And obviously in fire, as I said, the load performance will drop.
Okay, ma'am. Mr. Maskan asks, can you elaborate on how to calculate full tension capacity when governed with seismic bonding?
Full tension capacity governed by seismic bonding. So if I got the question right, so it's basically
Yeah.
your yielding of the bar under seismic conditions. I assume that's what they mean. So as I said, the force per bar that is coming. So maybe I just go back. Where did my share button go? Just give me a minute. Uh, Sorry, just 1 minute. So it's given in the guidelines. So it's for, I'm having some trouble sharing the document, but for seismic condition, it would have an impact on your bond value, basically. So the assessment documents that I just shared, they also have certain tests, some cyclic tests to check the bond value when it comes to seismic conditions. And when you plug that bond value in those equations, whether it be Carsten or the other documents, then you will be able to utilize it. In very basic principle, that's what it happens. So you just evaluate it and then take it.
Yeah, ma'am,
So
Mr.
yeah, I see the question. Does it change when seismic when it comes in picture of retention? Remains the same. Obviously, if the bond drops, I mean, you would need higher lengths to be able to cater to the same thing. So it would change. But
Okay,
but
ma'am.
if under the static and seismic, the bond values, for example, the approval document that I was showing, in those two cases for static seismic, the bond values were same. So in that condition, it doesn't change. I mean, I would expect the same embedment value if I'm getting the question right. So
Yeah,
sorry.
ma'am, Mr. Gopal Krishna asked the question. I am allowing him to talk.
Yeah.
Yes, hi ma'am. Good evening.
Good
Regarding
evening.
the question of joggling of revars, no, actually, insights what happened, what I wanted to ask, when the concreting is poured and due to lack of supervision, the rebars are or maybe like they get displaced during the vibration of like the needle vibrator. So what happens after concreting has been done? When we come from ground to say first level, then rebars are out of center line, maybe 100 mm or 125 mm. Then what the supervisors or laborers try to do, they bend back the same to original as per IS 456. So in that case, like somewhere, some say that a Hilti could be used to like maybe take 1 meter bar and like say 300 mm you do rebarring by the something your chemical and then send 50 mm is outside and then on that you do the lapping and then it can be done. So I wanted to ask how is it officially is it how useful is this or like should we do it? So can you please throw light on this, ma'am?
I'm not familiar with this specific application. Shonak, have you come across this in India?
Yeah, basically, what he's asking is basically what happens if the bars are then joggled. Instead of doing that, can we still do the rebarring and extend the reinforcement and then do the lapping instead of rebending the part to its original position? So I think this is a common. This can be done. There is no
The
challenge.
column
Or
extension, basically, right?
the column extension,
Yeah,
yes.
yeah, yeah.
So the only thing it has to be done is we have to ensure the right embedment depth, and just that it is an extension application, then we have to also ensure the embedment depth is adequate to transfer the stresses from the new reinforcement to the existing reinforcement. That is a bar to bar lapping that we have to ensure through anchorage.
So, sir, like the does the European code that you referred talks about this because IS 456 talks only of the slope in the like joggle. Like that is 1:6. It does not allow officially to do rebarring and if like we recommend that it should be like broken and then rebuilt like since the start until unless like unofficially you want to go ahead with the project. So does the European code that we were referring in the presentation have some like
As far
connotation
as I
towards
know,
this?
the Eurocode does not have specifically on that. It does not have.
Sir,
All right.
application wise, if we talk about this, maybe what I Kamalika add on to your point, uh, uh, Even IS also talks about the application of post-install rebarring, mostly in case it has to be something has to be modified or extended or strengthened. It's more in that application it's being referred to. But this is an application where your column also has to be extended, and that is an alternate way of doing it. I mean, you can bend it and do it, but that kind of also hampers the strength of the bar. So this is an alternate way of extending the column.
Thank you so much, sir. Thank you, ma'am.
Yeah.
Yeah, ma'am. One more person raised their hand. I'm allowing to talk. Hello, Mr. Mohammed.
Yes, hello.
Yes, please ask your question.
Actually, I have three questions, but it is to do with the same question. First of all is bar diameter and drill diameter. Is there your chemical has specified this or not yet? Because this is to do with the grout thickness around the bar within the hole.
So
And
yeah.
yeah.
So
And
the drill
my
diameter
third
I've
point,
mentioned for all the products. What specific drill diameter is needed?
yeah, so it is in the catalog directly.
Yes, catalog or the approval
Yes.
document. Yes.
Okay. Second part of this one is, suppose during installation, our bar drops to one side of the hole, then that part, I mean, the thickness of the the grout is changing. It's somewhere it will be bigger and somewhere it will be reducing. So is there any advice on that one, the efficiency, how it will reduce the efficiency? Because your embedment length and efficiency of the dowel is depending on the uniform thickness of the grout itself.
Yes. So that is taken care of in the installation safety factors. So in the various installation direction, you may end up in a situation where bar is bigger, you have put it and it goes down and the adhesive is coming. That's okay. I mean, for in cases where you can manage to probably somehow support the rebar so it stays, if not exactly centered, at least somewhat supported, it's better. But yeah, that would be the practice. So wherever we can, we try to support. If not, um,
So,
I mean, it depends on the situation.
so your product is coming with this, say, some support system which can be installed with the bar, like chair
No,
we
no,
have.
no. It would be like some arrangement you would have to do at the job site to support the rebar.
Some, yeah, then it is depending on the person to person. But anyway, that was the question. So we don't have any study about the efficiency reduction in that case.
No, we have. So as I said, the installation safety factor comes, and I was myself a test engineer, so I have installed Rebar. So I do know, officially I cannot answer you, but I do know that they do perform. I mean, it would have an impact, but that is taken care of in your factor. But that won't be my official answer. So you would have to support it. But we do, when we do the testing, we do check different iterations that can go wrong.
Okay. Yeah, okay. Okay, thank you, ma'am. Thank
Yeah.
you very much.
Yes, sir, these are
So,
the only questions. Yes.
so Engineer Kamalika, excellent presentation. IS Secretary is grateful to you in spite of your not good health. You could spare time and share your experience. Then this is the end of the year, so wish everybody Happy New Year. The next lecture would be again on the first day of January by our President, Dr. Pradeep Kumar. So, make a note. And then I would again request that anybody who wants to share knowledge through this platform can contact me so that we can make use of his knowledge by inviting him and making use of his experience for the benefit of structural engineers. So once again, thank you very much, the speaker as well as the participants for sparing their time and making use of the experience of Engineer Kumalka. Thank you.
Yes, sir.
Thank you,
sir.
sir. Thank you.
Thank you.